Okay, this time I'm going to do it. I walked away. I was clearly not wanting to do this. Uh, but I have to. So I got some paper because the acuplacer wants paper. So I did do, how long did I go through? I did get to 3 minutes of it, and then I walked away for a while. I better start it over because I'm not going to understand this if I don't. Okay.
In this
We'll
solve-along video
explore
we'll explore
how
how
to
to factor out the
the greatest common
factor in
in
various polynomial expressions. The
The
techniques you can use for factoring polynomials are pretty
varied.
varied, but the most basic one is to factor out
the
the greatest common factor, or GCF.
Master this
Master this fundamental technique and you'll be dominating your exams. Finding the GCF of big numbers is pretty easy at this point.
You
You just look for the biggest factor between two numbers.
But
But
several
students told me before that they get confused when
it's time to find
it's time to find the GCF of polynomials. I mean, how are you
how are you
supposed
supposed
to
to
find
find the greatest
common factor from this gibberish-looking combination
of numbers and letters?
of numbers and
Right.
letters? Right now you actually don't have to
You actually don't have to worry,
worry because I'll make the concept simpler.
simpler
For you, the greatest common factor of
The greatest common
polynomials
factor of polynomials
is actually just the product of the greatest common constant
and the greatest
and the
common
greatest common variable or
variables.
variables. Take a look at this
Take a
example.
look at this example. The
greatest integer that divides evenly into 7,
negative
negative 30. Pretty, and that's there will be a
The
solving
video.
each your all right music. In this
find
case,
the
that
greatest
constant is
common
13.
variable by fact.
You can find the greatest common variable. Music. You can find the polynomial. You're correct. Solving
Playing
each
the
problem, you
video
can pause the
to
video
see if you're correct.
to solve it on your own first, and then continue playing the video to see if you're correct. Alright, let's start to factor out the greatest common
factor in various polynomial expressions.
Music.
I'm at two. The greatest common factor is 13y cubed. And I've simplified it to 13y cubed with y squared minus 2y plus 4. That's not visible at all, I don't think. What do I do after that? I don't know.
You can find the greatest common constant by factoring the coefficients 13, 26, and 52. In this case, that constant is 13.
You can find the greatest common variable
by factoring the variables in each term. In this case, that is y cubed. Multiply the greatest common constant and the greatest common variable so that you find the greatest common factor, or GCF, which is 13y cubed. Use the distributive property to factor out 13y cubed from each term. And the final answer is 13y cubed times y squared minus 2y plus 4. Don't forget to check your answer by expanding it using polynomial multiplication as shown in this video.
Music.
Oh, I forgot to turn the microphone off. Okay, so this one is 8x to the 6th minus 36 to the 4th plus 20y squared. So y squared is in common in the number 4, it seems. So 4, not y, x 4x squared. The 4x squared is the greatest common factor. Dividing it out, you get 2x to the 4th minus 9 x to the 2nd plus 20, 5 plus 5. Okay, and that all multiplied by the greatest common factor. How did I do?
You can find the greatest common constant by
factoring
the coefficients 8, factor and 20. In this case, so that you or g use the district from each term minus it using by the way, please by liking this video, and if you are new to our channel,
Got it. Do I need to do more of these? No, I don't need to do more of these. Is that my Yeah. Okay. So we did enough of those. That was the greatest common factor. What I really wanted, okay, factor by grouping. Factor by
you
grouping
haven't seen that video yet, then be sure to.
Yeah, it told me to watch the
click the I.
GCF.
Is one level above the GCF method, so if you have no clue what it is about, or you haven't seen that video yet, then be sure to Click the I button because it is absolutely essential for this. Solve a long video without that knowledge.
Without that knowledge,
I
can pretty much guarantee that you'll be making these facial expressions watching any video about how to factor by grouping. Factoring by grouping is often used for polynomials containing 4 terms, and it's quite like an intermediary technique before you proceed to factoring. General quadratic trinomials. This can be quite tricky at times, so I'd like you to think of it as one of your smartphone or desktop puzzle
games.
And on we go, there will be a 3.
There will be a
3-second countdown before I start solving each problem.
You can pause the video
to solve it on your own first,
and then continue playing the video
to see if you're correct.
Alright,
let's learn how to factor by grouping in various polynomial expressions. Music.
Alright, what am I looking at here? Group. Well, I don't know. Oh yeah, they do group, don't they? Okay. So in the first step, I can divide out 2b. That's 2b. No, it's, yeah, 2b times. So it's w minus 3v. And the second would be 5. This is 5 plus 5. And w minus 3. Did I do it right?
Group 2 pairs of terms and work on them separately. The pairs of terms are shown using the orange and red
boxes.
Boxes factor out the greatest common factor.
From each pair of terms.
These GCFs are
that's what I got.
2b and 5.
No.
Factor out the common binomial.
Factor out the common binomial factor,
which is w minus 3v.
W minus 3v.
You can then combine the GCFs from each pair of terms.
What? Oh, I keep going. I didn't see right in front of me. So what does that leave me with? The w minus 3v. That leaves me with the 2b plus 5?
So that they form another binomial factor, which is
2b
plus 5, and the final answer is 2b plus 5 times w.
Is 2b plus 5 times w minus
3v. Don't forget to check your answer.
Don't forget to
minus
check your
3v.
answer.
Don't factor out the greatest common factor from each
there is
pair of
no
terms.
common binomial factor again.
These GCFs are x and negative 2.
I get the technique. And I'll remember it. Oh, excuse me. I forgot the microphone again. Which means the audio has been terrible. But nobody's watching. If they are, I'm sorry. So, I need a different form. I guess I just want to factor polynomials.
Polynomial multiplication. You learned how to expand expressions by
Think of
multiplying polynomials to make the concept simple. Think of
polynomial
factoring
expressions
polynomial expressions as the opposite of expanding expressions
An
into a
example,
multiplication,
polynomial
and because we
3x
identified
plus
this
12
common factor,
has
we
been
can now rewrite the whole.
DDF, or
The rule of thumb
greatest
is that
common
we
factor.
always look for
When
the
factoring-
highest doesn't end
to
there.
make
It is quite
mistakes when
common for beginners.
The polynomial
Factoring means
expression
that you have
were
to
given.
figure out
And in this case,
what got multiplied to produce the polynomial. At
common
first
constant
glance there
between
doesn't seem
6
to
and
be
z
any
squared
kind of
and
common
9.
factor because
There is no common variable.
there is no common constant
either.
between 16z squared and 9, and there is no common variable. 16z squared is
4z
equal to
squared
4z
minus 3 squared.
squared, and 9 is equal to 3 squared, and we now have like this by getting lots of practice.
Here is a list of common identities that you should familiarize
Identities. Here is a
yourself
list
with.
of common identities.
Remember them, and you will have
and you will have a much easier time.
easier time
Factoring polynomials. So to summarize the lessons in this video,
I know I'm not going to remember. So where were we? Everybody did. Is that enough for me to do my test? Oh. Maybe. No. Wait. Yeah, I'm still in question 3. 3x squared plus 25x minus 18. So three. Is my microphone on? Yeah. So 3 minus 18 is... No. I can multiply them by... the coefficient and the constant together. I remember this. 3 times negative 18. I don't know, remember why. 3 times negative 18 equals negative 54. So now I need to find what numbers go into make up 54. So do it step by step. Greatest common factor, whatever. 54, where half of it is 27. 27 and 2. We also have 9 times 6 or 5. 6. 9 times 6. And we also have 3 times 18. So, which pair gives me the middle term? So I think it's 27 and 2. 27 and times negative 2 equals negative 54. 27 minus 2 equals 25, which is the middle term. So 27 minus 2 equals plus 25. So 27 and 2. What do I do with that information? Substitute. So what I get is 3x squared plus 27x. Is this right? Times. Oh, is it times? No, it's wrong. Oh. Yeah, what do I do now? I didn't learn this format. Okay, I gotta go back to the video. I need... Is it a special case?
Welcome to Teach Me Animated Math.
To Teach Me Animated Math.
In this explainer video you will learn how to identify
and
simplify special case products in polynomials.
Algebra puzzles.
And after you get familiar with these patterns, you'll be a godlike machine that can easily dominate algebra puzzles with polynomial special case products. So what are these polynomial patterns? These basic patterns for special case products are known as the perfect square, trinomials, and difference of squares. If your goal is just short-term benefits, then it is okay to just memorize these patterns, but if you're after excellence and long-term benefits, then you should understand how to recreate these patterns yourself. Don't worry though, because I will show you how to do this step by step in this video, and if you play a lot of games, then you're aware that there is often a skill tree used as a guide for unlocking more advanced skills. Welcome to Teach Me Animated Math. So what is a polynomial function and examples of it? In the second part of our introduction to polynomials, we'll discuss the technical description of polynomials. And after watching it, you'll be able to identify which functions are polynomials and which functions In this solve-along video we'll explore how to factor quadratic trinomials with leading coefficient 1, and we'll do this extensively so that you can dominate your exams. There are plenty of scenarios for factoring general quadratic trinomials, which is why we split it up in bite sizes, so that it is much easier to understand. This is the first part, and we'll focus on factoring quadratic trinomials with leading coefficient 1.
At this point, you should already be comfortable with factoring
polynomials using the GCF method and by grouping. So if you have no clue what they are, or if you haven't seen our videos for it yet, then be sure to click the I button, because if you don't have that knowledge, I can guarantee that you'll be making these facial expressions watching any video about factoring quadratic trinomials with leading coefficient 1 quadratic.
Quadratic trinomials with leading coefficient 1. Quadratic
trinomials follow the form x squared plus bx plus
c.
For the coefficients a, b, and c are integers with the restriction that a cannot be equal to 0 when a trinomial has a leading coefficient 1. It means that it is equal to 1 to understand the basics for factoring.
To understand the basics for factoring quadratic trinomials,
first consider this example
of multiplying two binomials.
Now, to factor a trinomial, you'll have to
reverse this
process, which is why if you imagine it already, it can involve a lot of guesswork, and to greatly simplify that process, we will only deal with quadratic trinomials with leading coefficient 1
in this video.
And of course, having extensive
practice in multiplying
polynomials
will give you some kind of
sixth
sense and reduce that guesswork
by a huge factor.
So
on we go. There will be a 3-second countdown. Before I start solving each problem, you can pause the video
to solve it
on your own first, and then continue playing the video. To see if you're correct. Alright, let's learn how to factor quadratic.
Let's learn how to factor quadratic
trinomials with leading coefficient
1.
Music. Write the trinomial in factored form and include the blanks that we'll fill out
later on.
Later on, there are 2 signed blanks for the coefficients and 2 yellow blanks for the constants. The product of the first terms and the binomials should be equal to w squared,
which means that
its coefficient is just the integer
1. And the only factors in this case is 1 and 1. As mentioned earlier, we will only be factoring quadratic trinomials with
This means that leading coefficient 1. This means that the coefficient of the first terms and the binomials will always be equal to 1 moving forward. This will greatly simplify the factoring.
I didn't forget the mic. Good. Here's the mic. Okay, it's not the one I was looking for. Non-one leading coefficient. I think that's it.
In this all-the-long video, we'll explore a faster way to factor quadratic trinomials with non-one leading coefficient,
and we'll do this extensively so that you'll be
unstoppable in your exams. There are plenty of scenarios for factoring general quadratic trinomials, which is why we split it up in bite
sizes so that it is
much easier to understand.
This is the third part.
And we'll focus on
factoring of quadratic trinomials
with non-one leading coefficient. So if you have no clue how to factor quadratic trinomials with non-one
leading coefficient,
or you haven't seen our video for it yet, then be sure to click the I button. Because if you don't have that knowledge, I can guarantee
that you'll be making these facial expressions. Watching any video about this topic.
Factoring quadratic trinomials
with
non-one leading coefficient is quite tedious with all of its
trial and error.
An error, right? But what if I told you that you
can significantly reduce the number of combinations to test for?
And no, I'm not kidding.
There really is a method
to all this madness. You can
actually make it
easier using the concept of
greatest common integer
factors or simply common factors. Let me show you.
Any trinomial that has
the greatest common factor of 1
is guaranteed to have binomial factors that also have 1 as their greatest common factor.
This means that you can eliminate
candidate binomial factors that have a common factor greater than 1.
Let me repeat that. You can eliminate candidate
binomial factors
with common factors greater than 1 too.
To tremendously reduce the amount of trial and error you have to do. Don't worry if you can't imagine how to apply the concept at this point, because I will show it to you step by step.
So on we go. There will be a 3-second countdown before I start solving each problem. You can pause the video to solve it on
your own
first, and then continue playing the video to see if you're correct. Alright, let's learn the faster way to factor.
Let's learn the faster way to factor
quadratic trinomials with non-one leading coefficient. Write the trinomial in factored form and include the blanks that we'll fill out
later on. There are two cyan blinds for the coefficients
and 2 yellow blanks for the constants.
The product of the first terms and the binomials should be equal to 2x squared. The factors for this are obviously limited to just 2x and x. So let's write it down.
The factors of 10
The factors of 10 can be broken down into these four combinations.
Fill in
all
all
the combinations of the factors of 10 in the yellow
factors of
boxes.
10 in the yellow boxes. Now
this is where things
become
interesting. Instead of
going straight to the trial
and error
method, we can be a little bit lazy and eliminate
some of the candidate factors
using the concept of common factors.
First things first, look at the
quadratic trinomial and
observe
that its terms do not have a common
integer factor aside
from 1. This means that the binomial
factors we are looking for
cannot have a common
integer factor aside from 1
as well. If you inspect the second and third candidates, you can
see that there are
common integer factors for the
second candidate, 2x and 10 have a common factor of 2, and
for the third candidate,
2x and 2 have a common factor of 2. This process allows us to eliminate candidate factors without doing polynomial multiplication.
Amazing,
isn't it? Now
we can proceed to the trial and error method for the remaining binomial
factors.
Multiply the first candidate factors.
The resulting middle term is 21x.
This is
an incorrect candidate.
Multiply the fourth candidate factors.
The resulting middle term
is 9x, which is what we are looking for the final answer.
We are looking for. The final answer is
2x plus 5 times x plus 2. We were able to
eliminate only 50 of the candidate factors just because this is a relatively
later on. The product of the first terms of
the possible factors
binomials should be equal to 10x squared. The possible factors for this are x
times 10x
and 2x times 5x.
Fill in the sign blanks with the possible factors of 10x squared.
With the possible factors of 10x squared, since both the middle and last terms are positive, it means that the factors of 5 should be
There's my microphone. So here I was before. I should do this on paper. Did I do this on paper? I did do it on paper. I started to. That's where I ended up with. Yeah. Yeah, 13 left. So now, do I do this again? Do I... No. I don't think so. Where do the Y's come from? Aha, it's a totally different question. Oh. There it is.